Have you ever wondered what would happen if the very heart of our planet, the Earth's core, suddenly stopped spinning? It's a mind-boggling thought, but understanding the core's role is crucial to grasping the potential consequences. The Earth's core, composed mainly of iron and nickel, is divided into a solid inner core and a liquid outer core. This dynamic system generates our planet's magnetic field, which protects us from harmful solar radiation and plays a vital role in maintaining life as we know it. Now imagine if this spinning core came to a halt. The implications could be catastrophic. Without the movement of the outer core, our magnetic field could weaken or even collapse, exposing us to increased radiation and potentially devastating solar storms. This could lead to widespread disruptions in technology, from GPS systems to power grids, affecting everything from communication to transportation. In this video, we'll dive deep into the science behind the Earth's core and explore the chilling possibilities of a world where it no longer spins. Buckle up, because the journey into the unknown is about to begin, and the stakes couldn't be higher. To truly grasp the significance of Earth's core, we first need to understand its structure. The Earth is composed of three main layers: the crust, the mantle, and the core. The core itself is divided into two distinct layers: the solid inner core and the liquid outer core. The inner core, with temperatures reaching up to 9,932 degrees Fahrenheit, is primarily made of iron and nickel, while the outer core, which surrounds it, is a swirling mass of molten metal. The movement of the liquid outer core is crucial for generating Earth's magnetic field through a process known as the geodynamo. As the molten iron flows, it creates electric currents, which in turn produce magnetic fields. This dynamic interaction not only forms the protective magnetic shield around our planet, but also stabilizes our environment, making life possible. Without this magnetic field, Earth would be vulnerable to solar winds and cosmic radiation, which could strip away our atmosphere and lead to catastrophic consequences for all living organisms. Thus, the core's movement is not just a geological phenomenon. It is a fundamental aspect of maintaining life and stability on Earth. Understanding this intricate system helps us appreciate the delicate balance that sustains our planet. To understand the hypothetical scenario of Earth's core suddenly stopping its rotation, we first need to explore the forces and processes that keep it spinning. The core's rotation is driven by the convection currents in the molten outer core, which are influenced by heat from the inner core and the Earth's rotation itself. This dynamic system creates a complex interplay of forces that not only sustains the core's movement, but also generates our planet's magnetic field. If the core were to stop spinning abruptly, the immediate effects on the Earth's magnetic field would be profound. The geodynamo process, which relies on the movement of molten iron, would falter, potentially leading to a rapid weakening or even a complete collapse of the magnetic field. This could expose the Earth to harmful solar radiation, resulting in increased radiation levels on the surface. Moreover, the concept of inertia plays a crucial role in this scenario. The Earth, with its massive size and momentum, would experience significant disruptions. The sudden halt of the core's rotation could lead to shifts in tectonic plates, causing earthquakes and volcanic activity. The inertia of the planet would also affect atmospheric patterns, potentially resulting in chaotic weather systems. In essence, the sudden stop of the core would unleash a cascade of catastrophic events, reshaping life on Earth as we know it. If Earth's core were to suddenly stop spinning, the immediate consequences would be nothing short of catastrophic. One of the most alarming effects would be the rapid loss of the magnetic field. Without the geodynamo process fueled by the movement of the molten outer core, our planet's protective shield would weaken significantly. This would expose Earth to harmful solar radiation and cosmic rays, leading to increased risks of radiation sickness and potential damage to the ozone layer, which protects us from the sun's harmful ultraviolet rays. Geologically, the repercussions would be equally severe. The sudden halt of the core's rotation could trigger increased seismic activity, as the stress on tectonic plates would become unmanageable. We could witness a surge in earthquakes and volcanic eruptions, reshaping landscapes and displacing populations. Moreover, the impact on technology and infrastructure would be profound. Many systems, including GPS, satellite communications, and power grids, rely on the stability of the magnetic field. A collapse could lead to widespread failures, causing blackouts and disrupting essential services. Air travel would also be affected, as increased radiation could pose serious risks to aircraft and passengers. In essence, the sudden stop of the core would unleash a chain reaction of events, fundamentally altering life on Earth and challenging our technological advancements. If Earth's core were to remain stationary, the long-term effects on our environment, climate, and life would be profound and far-reaching. One of the most significant changes would be the alteration of atmospheric conditions. Without a functioning magnetic field, solar radiation would bombard the Earth, leading to increased temperatures and erratic weather patterns. This could result in extreme climate changes, such as intensified storms, prolonged droughts, and shifts in precipitation patterns, fundamentally disrupting the delicate balance of our climate system. The implications for ecosystems and biodiversity would be equally dire. Many species rely on stable environmental conditions for survival, and the increased radiation could lead to habitat loss and extinction. Coral reefs, which are particularly sensitive to temperature changes, could suffer catastrophic bleaching events, while terrestrial ecosystems might struggle to adapt to the new climate extremes. This loss of biodiversity would have cascading effects on food chains and ecosystem services, threatening the very foundations of life on Earth. In such a drastically changed world, human adaptation would be a monumental challenge. Communities would need to develop new strategies for food production, water conservation, and shelter from extreme weather. While some may find ways to adapt, the overall survival of humanity would depend on our ability to innovate and collaborate in the face of unprecedented environmental challenges. The future would be uncertain, but resilience and ingenuity would be our greatest allies. When it comes to the dynamics of Earth's core, scientific theories and expert opinions provide valuable insights into the likelihood of the core suddenly stopping its rotation. Most geophysicists agree that such an event is extraordinarily rare, if not nearly impossible, given the immense forces and energy involved in maintaining the core's movement. Research indicates that the core has been spinning for billions of years, driven by convection currents and the planet's rotation, making a sudden halt highly unlikely. Historically, there have been no recorded instances of the core stopping, and geological evidence suggests that the core's dynamics have remained relatively stable over geological timescales. However, scientists continue to study the core's behavior through advanced seismic imaging and computer modeling, revealing fascinating details about its structure and movement. These ongoing studies help us understand the complex interactions between the inner and outer core and their influence on the magnetic field. Recent research has also explored the potential for gradual changes in core dynamics, such as fluctuations in rotation speed, which could have implications for the magnetic field. While the prospect of a complete stop remains a theoretical exercise, these studies underscore the importance of understanding Earth's inner workings. By continuing to investigate the core, scientists aim to unravel the mysteries of our planet and better predict its future behavior. In this video, we've explored the fascinating dynamics of Earth's core and the potential consequences if it were to suddenly stop spinning. We learned that the core, composed of a solid inner core and a liquid outer core, plays a crucial role in generating our planet's magnetic field, which protects us from harmful solar radiation. The implications of a stationary core could be catastrophic, leading to climate changes, increased geological activity, and significant challenges for life on Earth. As we wrap up, it's essential to recognize the importance of understanding our planet's inner workings. The Earth's core is not just a geological curiosity. It is vital for maintaining the stability of our environment and the survival of countless species, including humans. If you found this video intriguing, we encourage you to subscribe to our channel, like this video, and share it with friends who might also be curious about Earth's mysteries. Your engagement helps us create more content that dives deep into the wonders of science.